Okay, let us see improper integrals type 1. Like I said in the previous video, type 1 has 3 types of limit. Okay, you see the first one is from a to infinity. The second one is from negative infinity to b. And the third one is from negative infinity to infinity. Okay, so we can say that fx is continuous in the interval a to infinity. Fx is continuous in the interval negative infinity to b. And fx is continuous in the interval negative infinity to infinity. Okay, now how to solve these all integrals when the limits are infinity. Okay, so the first one we look at, the limit is from a to infinity. So we cannot integrate if the limit is infinity. So the infinity is not bounded at any point. Okay, for example, this figure, you can see that integrate from 0 to infinity. So we know that 0 is here. So this is bounded limit. And then 0 to infinity. So this one is not bounded. So we don't know until when, right? So what you can do is you can let one point here, which is t. So let's say we plot t here. Okay, this one. So now the region is bounded. Okay, from 0 to t. Okay, so for this one, you can change integrate from a to t. So when you look at this figure, so t approaches to infinity. Okay, when we talk about approaches, so means that we need to put limit. So limit t approaches to infinity. So you see here, you put limit t approaches to infinity, integrate from a to t. So this infinity you change to t. Alright, so fx dx. Okay, now we look at the second one, which is from negative infinity to b, fx dx. So same thing, let's say you have this graph and then this is b, so negative infinity to b. So you can replace negative infinity with t by adding the limit t approaches to negative infinity. So similar with number 1. Okay, now after you find the limit 1 and 2, okay, 1 and 2, and then if the limit is as is, this limit is said to converge. Alright? Okay, what is the meaning of as is? Okay, let's say you integrate fx dx and then you get any value, real number. Okay, so this one is as is. Okay, but if the limit is thus not as is, okay, means that if you find integrate fx dx and then let's say you get infinity, so this one is thus not as is. So we call the limit is said to diverge. Alright, so if the limit is as is, so we say the limit is converge or convergent. And if the limit is thus not as is, we say that the limit is diverge or divergent. And now the third limit for type 1. Okay, you have negative infinity to infinity. So you can split into 2, which is from negative infinity to c, any value, any real number, and then start with c, okay, to infinity. Okay, so you have 2 integral here. You divide by 2. 1 integral you divide by 2. Okay, I repeat again, negative infinity to c and then plus c to infinity. Okay, remember this infinity is lower limit, then the upper limit is infinity. Okay, and then you check whether the limit is as is or not. Okay, so if as is, we say that the limit is converged. So okay, if both term is converged, we say that this limit, okay, negative infinity to infinity fx is converged. Alright, and then if either term is diverged, okay, for example, only one term is converged and then one more is diverged, so we say that the limit is diverged if either one is diverged. Okay, if either one is diverged, we say that this one is diverged.